Okay, many of you chem students already know this, but let's talk about half-lives. So here's a problem you might have. Arsenic-74 is used to locate brain tumors. It has a half-life of 17.5 days. What half-life means that in 17.5 days, this sample or this milligram, whatever this arsenic-74, will have half of it left. And that happens in 17.5 days. So we need to write an exponential decay. Clearly we know it's a decay because half of it is going to remain after 17.5 days. Function for a 90 milligram sample. Use the function to find the amount remaining after 6 days. So there's our exponential equation, y equals a times b to the power of x, that we've been working with. So in this, our initial sample is 90 milligrams, so there's our a value. Our b is 1/2, since we're referring to half-life. And typically our x is the amount of years or days or months or whatever it is we're referring to. Well, in this case, because it has a half-life of 17.5 days, we have to raise it to the power of 1 over 17.5 times x. So that's why I have 1x over 17.5. And x is representing the number of days. So to figure out the time remaining after 6 days, we would have y equals 90 times 1/2 to the power of 6 over 17.5, which that is about 70.963. So actually about 71 milligrams remains after 6 days. Okay, compound interest. So something else we'll learn this lesson is a compound interest formula. As you can see, it's an exponential formula, or exponential growth formula. In this case, we have a equals p times 1 plus r divided by n to the nt power. I'm going to go through and explain what each of those values are. But first, let me explain that p is actually like our initial value, ra. I just couldn't find an equation online that had an a there instead of a p there. So if you would rather write it with an a, go for it. And then the amount value, the a that's already there, you can change it to y equals. And then our growth rate is there in the middle, 1 plus r divided by n. Now the real reason it's not just 1 plus r, like it had been in the previous lesson, is because now we are throwing in the n variable, which is the number of times it is compounded in 1 year. So all the other times it wasn't compounded, it just happened once that year. So you didn't have to incorporate the n. Well, now we do. So n is the number of times interest is compounded per year. R is the interest rate as a decimal. T is the time in years. P is the principal, or the original amount that we already discussed. And that n in the exponent is the same n that's in the r divided by n. So let's talk about what that n value is. So like I said, number of times it's compounded per year. So you might be told that it's compounded annually, n would be 1. Compounded monthly, n would be 12. Compounded semi-annually, n would be 2. Compounded quarterly, n would be 4. Compounded daily, n would be 365. So you have to look at the problem that you're given, and it will tell you it's compounded blank. By that value, you have to know, or by that word, you'll know what the value of n needs to be. So let's go ahead and look at an example here. Okay, here we are told the problem to suppose you invest $1,050 at an annual interest rate of 5.5% compounded quarterly. So how much money to the nearest dollar will you have in the account after 5 years? Okay, so for this, use our formula. So a equals, or y equals our initial value, so $1,050, parentheses 1 plus r, so that percentage as a decimal is 0.055 divided by n. N is the number of times it's compounded in a year. So quarterly, there are 4 quarters in a year, so that's where my 4 came from. And we're going to raise it to the power of n times t. Well, n is 4, and since we are told time is 5 years, 4 times 5 is 20. Once you have that, you can pretty much type that in your calculator, and you get $1,379.77, or rounded to the nearest dollar, it would be $1,380. So that's how much we'll have in our account after 5 years. Okay, there's something called compounded continuous interest. The formula is there. A equals P times E to the power of RT. Again, that A for the amount can be replaced with the Y, and the P can be our typical A value, our initial amount. Now E, this might be new, especially for those of you not in chemistry. E is a mathematical constant. It actually has a value. If you typed E in your calculator and hit enter, you would get a number like 2 point, actually let me type it in quick. It's 2.718. It's kind of like pi. It's a number or symbol that represents a number. T is time in years, and R is the interest rate, again, as a decimal. So this is the exact same problem we had before, except let's look at, there's one difference. It says, suppose you invest $1,050 at an annual interest rate of 5.5% compounded continuously. See how now it says continuously instead of quarterly? Because it says compounded continuously, we have to use this formula. How much money to the nearest dollar would you have in the account after 5 years? Okay, so here our initial amount or original value is $1,050. E, like I said, is a value, so we keep E and raise it to the power of 0.055 times 5 for 5 years, and we get 0.275. So that's where that 0.275 came from. Once I type that in my calculator, I get $1,382.36. So that rounded to the nearest dollar would just be $1,300.82. Or sorry, $1,382. And that's pretty much everything you need to know, all the formulas that you'll have to use for this unit. Now go ahead and try the checkpoint quiz. Have a good day.